We've got two cameras to have a look at today. They're both the same model, JVC KY-15 they've both got viewfinders, although this one I've already taken apart. We can have a look. These cameras have a removable back part, so you could put a VCR or some sort on there, but they've come with the remote connector for a studio or separate recorder type situation. Standard 12-volt power input. There's an earphone connector. There's S-video output, a Genlock input, intercom. There's a test output. I presume that's the video. Maybe you can choose other things to go on there. There's microphone input there. There's also that, which I guess is some other type of microphone. Probably when you put that into the stereo setting, it probably uses this for some special JVC microphone. On the other side, there's the filter settings and then usual controls there for gain, bars, and some automatic preset settings. Oh, that's for white balance. Display select. And then around the front is VTR control, an auto setup button, and the lens has got the usual connectors on it. Different lens connector again to what we saw on the previous cameras. This one just plugs without a locking ring on it. Seems a little bit cheaper. Yeah, the lens is quite long. It's like it's got an extension tube on it to make it real good and zoomy. 7 to 112 millimeter. So I haven't powered these up yet. Perhaps we should start by doing that. We'll start with the one with a viewfinder still on it, and then we can swap that viewfinder over for the other camera. So this is the same thing. It's just got this very bizarre tall handle on it. Presumably that's because it had a VCR there that went up to there. Maybe. It's quite strange. Anyway, let's turn this on. See what it does. I've got a monitor here. Put it on bars first to start with. Video signal to the test output connector. Although that's had a knock and it's bent. Cable's gonna get munted if I keep plugging it into dodgy plugs. Anyway, let's get some power into this. And let's put that to... And there's no current draw. Okay, that's not a very good start, is it? Unless there's a control. Ah, there's another power switch over here. Didn't point out before. So there's another power switch here. Remote VGR DC input, so we want that. There we go, it's starting up now. The output is black and white. Still got bars though. Bars show up on the viewfinder, so that's working. In camera mode though, yeah, I think it is working. The back focus, that's what the problem is. Yeah, it seems to work, it just doesn't have any color. There are also some buttons here, shutter and normal, but they're completely turned to mush. I don't want to touch those. Anyway, so the camera sort of works, it just is black and white, but unless the test output is always black and white, it's possible that it only outputs a particular color. We'll see what the other camera does, and then we'll decide which one to take apart. And DC input. Oh, look at that. Color bars this time. That's exciting, so that gives more promise. Yeah, but we get nothing on the camera. Ah, hang on. It's on the closed shutter. Have to watch that. So we get a color image there. And the white balance is weird, it looks green. Ah, the zoom lever is broken off. This lens might be in worse condition than the other one. But anyway, the camera is basically working, but yeah, the color looks a bit wonky. Anyway, okay, so let's take apart the other one, because this one seems to function more. So we'll take apart the other camera, the tall handle. Before we start getting into the camera, here's the viewfinder. I think I'd previously taken this apart on a video, maybe. Or it's at least been shown in another video because I compared it against another one, I think. Anyway, this looks like it's had a hard time. It's glued together there. These screws don't look original either. Maybe it's had some knocks. There we go, there's the tube. And look at that, there's some melting there, so it must have been pointed towards the sun at some point. So it's got a low light, record, battery, and alarm. So those are mirrored, because when you're looking at it, you're looking at it through that mirror. So if you wanted to use that directly, you'd have to swap around the horizontal deflection coils, swap the polarity of it. So that's got a JVC chip in it, which will be doing the sync separation and other business. Presumably this won't want to come apart anymore. I wonder if we should test this viewfinder before we destroy it completely. I should put it back so it doesn't short out. It's got some power device there, which looks like it needs to push on the bottom with this insulating pad. And then there was this ground wire that holds that board in place with a screw. Well, a screw that also includes a ground wire and holds it in place. Okay, that's probably enough to get this thing powered up. So we used the camera we're about to take apart. It's on bars. I'll connect this up. I think we should be alright with that. Yes, there you go. Got the bars. Ooh. Can see them there. So that is working. Just be careful with it because it's flapping about in the breeze. Viewfinder works. That's good to know, even though the housing is very corroded and in poor shape. But at least that can be used on another project. The eye cup on the viewfinder has also seen better days. Okay, we'll take the lens off. It's interesting how long that bit is there. That's something that I remember. I don't think any of my other lenses have a big long bit like that. So when you adjust this back focus, you can see that lens is moving in and out. I think that means the other one, maybe was it the Panasonic that had the broken lens mount? I think that this part was damaged because when I was turning it I didn't see anything unless it uses some internal adjustment. There might be a filter on the front, but it's been very dinged up. Anyway, it's quite a little unit. I'll remove the handle from the top. There's a vent, a mesh there, and it even has a part number. And the screws are retained. That's nice. It'll be this that holds the back on. Maybe another screw. Sure. Oh, that just holds the shoulder pad thing on. I don't know. We don't really need to take that off, but let's have a look under it anyway. I thought this thing would just slide apart. Maybe I have to undo those other screws. Now, here we go. Okay, that comes off. So this back part, the camera adapter KA20E. And yeah, is that a D37? Possibly. Looks like they had a nice dip in the sea or something. Yeah, so that's a camera there. There's a little door on the bottom. Let's see what's under that. Maybe that's a memory backup battery. No, it's two transistors. Okay, 7805. Is it 78005? And something that looks like a PNP transistor. They're usually green like that. Okay, we'll open up We'll take the sides off this, see what's behind them. Oh, it's got a seal there that ripped out of it. Okay, I think this is the back. Maybe. If it's a card frame, might not be. It's got some adjustments there. Black balance, H saw, preset black level, some kind of tack-on boards there. Interesting. Okay, let's have a look what's on this side. Wonder if those buttons got used a lot and that's why they've turned to mush. Finger juices on them. Or if that's just the material they're made of. It. Other ones like that there haven't degraded. All the ones on the front, so don't know. It's been exposed to something that's upset it. Ah, look at that. Nice little card frame. You see, you can choose with this control. Pretty sure that's what's going on here. You can choose with that what comes out of that test output. Fairly sure that's what that is there. So you can have it set to RGB or the encoded output. And we were taking apart the camera with the black and white picture, weren't we? But that is set to 3, which is the encoded output. So it should have been in color. Must have some other issue. So let's have a look at these boards. Oh no, I touched that thing. There's real mush. PR1. It's got little modules on it. Interesting. Is it because I was going to say they didn't want to do surface mount on this main board, but they have on the other side. They are gluing the stuff down. You can see the glue blobs. The little brown marks beside the components. So they've been glued down. I wonder if they've gone through a wave soldering process so that it does the through holes and the surface mounts at the same time in a wave. Not sure about that. They have glued down the ICs, but you'd expect feeding pads to be there if that was the case. And you can see the names of the modules on the other side. Okay, let's look at the next board. This is PR2. Similar sort of thing. There's a matrix control. A matrix. A bunch of adjustments again. Capacitors. And on the back, oh look at that, some bodges glued down with some gross looking glue. So that's 87, 88 date codes on these chips. CMOS stuff. 4000 series maybe? Yeah, looks like it. Yes, this looks like a 1988 SE board. And that interesting thing. Some Seoul style chips. A lot more modules again. More surface mount on the back. And the CP board. That CPU maybe? That looks CPU like. Oh, look at that, a medium width dip package. That's interesting. More modules with surface mount stuff on them. And I've got this little chippy on the back. Presumably some kind of CPU. So now we've got an enclosed area here which must hold all the CCD goodness. Okay, that all comes out of one piece, doesn't it? Oh, that's undone. I don't think I undid that. Someone been in here before and not put it back correctly or completely. Okay. That comes off. There's very weird stuff going on in here. There's one wire coming out of the cage, and there's other multi-strand which seems to just go to a board that only has one trimmer on it and nothing else. Oh, and one test point. But it's screwed in from the inside, we can't get that out. And a board with switches on it at the little board with those controls. It is down the bottom somewhere. Oh, I see. So we've got this top piece comes off of the housing separately. Let's do that. And there's probably more stuff to take off. Yeah, we probably have to take this piece off with the connectors on it. And then under that we've got to take off these screws. They're mounting this backboard to the top. It's not too bad, is it? Everything's fairly well arranged. Are there more screws? Oh, okay, so we only undid a bracket there. The actual screws are under it, and they're really loose. Someone's been there before and forgotten to put them back properly, or they've just rattled themselves loose over the years. Yeah, so look at that. Coming out of the top of this cage is a cable assembly that just goes to a trim pot and a test point. They call it VH subboard. Has it got anything else on it? There's some through, like wires going through there. Oh, it's got an IC on it. Strange. I don't know what the deal is having that coming out. There's the viewfinder connector. Oh, and those sticky controls that I just touched again. Not very nice. Looks like there's an LED too. Yeah, you can see the red there. Little LED. Let's unplug this and get those out of the way. And we'll unplug this cord coming off of here. And I'm wondering what else do we need to do to get the camera pickup part out. Still more screws holding it. And there's a large connector there, and then there's this double row connector there. There's only one shielded cable coming out of this whole thing, which goes onto that. But I don't think that would be the whole video signal, would it? The wires are quite nice and soft on this. I don't know. There isn't any other shielded wires coming off. Is this 3 CCDs or just one? I think it's 3. Oh, you can see what probably is one of them there on an angle. Let's take off this cage. Will that lift off now? Yeah, also the other thing is that filter turret thing, because that one screw was already undone. So that comes out, so it's possible to install a different one, I guess, if you want different filters. So this one doesn't seem to have any feedback to the camera of what you've got selected, like that other one, the Panasonic one, which had a little encoder switch thing. Oh, look how many screws are around there. Ah, there's a heatsink paste, so yeah, it was sort of pressing on the top of those. Sort of. Maybe not as well as I'd hoped it was. Strange. Let's just take it all apart. If we take these off, does that do anything good? I think that will take the outer frame off. So there's 4 there. To take the actual mount off, then you got heaps of screws. I wonder if they're loose. Yeah, that one's loose. I wonder why there's so many, and then it's just 4 screws to the actual housing. Now, to go any further, we have to pull this board off. So that's just connected. With some headers. Except there's bodge wires and other connectors, so we can't easily take that off. Okay. So we've got 3 CCD boards in here. R, G, and presumably B. Yeah, it says B on it. And then from those, they've got 1 shielded cable. See the red, the green, and then the blue one down there. And those come up to this board here. RGB, and also a brown wire which comes from something up here. So that will be the first set of amplifiers and things. So the video signal must come off on this cable, going with the 2-row connector, go into the top of here. So the video signal comes into here and then goes to various things as pre-black, or a preset black, and then various little buffery things presumably, and then a whole bunch of trim pots, and those signals go onto the main back plane and to all the other boards. So this black bundle of wires goes up to this top board, and then that has quite a lot of cables going to each of the CCDs, so presumably that's doing all the timing and power stuff for the CCDs. I think we can get that off now to have a look between them. There's some NEC chip, and then this thing, does that have, oh yeah, that's got 3 ICs on the back, more NECs, and some bodged on stuff. Ah, I think this is all a bodge, isn't it? That, the wires that go to that, are the ones that are soldered on the back side of that to various points and onto there. So that's interesting. I wonder if that's some kind of upgrade or add-on or mod that they've done to it. VH subboard. Might have a service manual for this. We might be able to look up some of this stuff and see what's going on. So if that was some kind of tack-on thing, they've found a way to mount it in the top here onto this little plate, and it's got a ground. And so this little tact switches under that thing. Gross has stuff on the top. Oh, the crust goes the whole way through. Even on these buttons, the crust is there. Wow, so that's fully perished the whole way through. I'm not sure if we're going to take this apart further. No, I suppose we should take this board off just for fun. Have a look under the other side of it. But perhaps I'll see if there's a service manual, and if there is, we'll have a look through that. There's this weird kind of frame thing mounts around with this other bracket. I suppose that exceeded their folding limit for metalwork to get something that went all the way around, so they had to put this bit in separate, I assume. We can't take this plate off with those little screws there because we can't get to that one unless we took the CCDs out or off, which I didn't know whether we want to go that far, do we? Yeah, that plate there, which is the heatsink on the back of the CCD. I think the CCDs are actually connected by headers and sockets. Let's have a look. Yeah, it looks like it. Machine pin IC sockets holding plugging the CCDs in. Yeah, look at that. You can unplug. It's also really a fine version of the machine pin IC sockets. So there's the back of the CCD. Should we take it out? Seems like we're going to fully wreck this camera. And yes, the parts of it are soldered onto this possibly ceramic plate there. It tells you about the connections there. V out. It's got H1, H2, T1, T2, T3, VL, V1, V4, V2, V3, sub. So where does the signal come off? So it's that little white wire there. So it's got a pull down by the look of it. And then it goes to that transistor. And to that, which I think is the leg of a capacitor, yeah. Am I reading that right? There's a guard trace around it. So it goes to that transistor, and then it goes through to the other side. Okay, and then there's a track which goes up to one of those pads. Oh yeah, it's V out. That makes sense, doesn't it? So V out into the transistor, and there's a capacitor, and pull down, and then the signal comes out. Goes on the shielded cable over to this board, RGB, and then those which are well shielded. The signals come in and go somewhere, probably to one of these 3 boards. Interesting, they got tantalums there, good smoke generators. And then the video signal must be high enough level after that it can come out on these unshielded cables. How much trouble are we going to get in if we take the CCD off? I guess I've smushed that thermal paste everywhere as well. That's good. Let's take off the CCD. We'll undo this clip. I don't know what happens after that. We're going to find out. So that's pushing down with a little strip. But I think that might be fixed down from the other side. which means we can't take it out. Yeah, I'm pretty sure it's got 4 screws in the corner holding that, but then that's been soldered together, so I don't think we're taking that off, unfortunately. So what was the point of that little brass or whatever clip thing? Weird. I suppose that just holds it down while it's being soldered. Yeah, so we can't do much with that, unfortunately. Well, unless we want to completely destroy this thing. So one day we'll do an investigation when I've decided I don't need this anymore. If we can get it plugged back in. Yeah, pretty straightforward. Are these all the same length? No. Yes, this is a regular 2.54 pitch header by the look of it. Quite interesting JAE brand sockets there, quite wide compared to the modern slim ones. Maybe they're really good quality connections. Real gold plated. Okay, pretty good. Yeah, there's like fungal bloom stuff growing on the IR filter as well. Yeah, that's a shame, isn't it? Can't really get rid of that. So maybe we should take it completely apart then. Well, I have got a service manual, so we'll take a goose at that later on, but for now we've still got some other bits and pieces to take apart. We want to have a look at the, I think it's power supply board down the bottom there, and we've also got this adapter thing to take a look inside. Yeah, I wonder if that was expected that the standoff would come off. Looks like it. So they've bottomed out a screw in this standoff so that when you unscrew it, it unscrews the standoff rather than the... Okay, so there's a flex cable that goes to that connector there. Oh, it's a 50-way. So there's a D50 there. The housing comes off as well. It comes apart more. There's some very loose screws here. Looks like this is getting the full treatment, doesn't it? A piece of cast aluminum type stuff. So that connector lifts out on a flex, although there's a ground wire there we need to get off. And that was also the only thing holding down the bottom board. Okay, so that can unplug. There you go, D50. Let's put some glue along there to help the bend. So it's double-sided flex. So now we're right down to the bottom. So there's where those front buttons. Oh, that's gross as well. So maybe that's already been replaced. So it's not that it didn't go bad, it's that someone's already sorted it out. You can see some residue there. Yeah, and there's stickiness all over that button there. Yeah, so I guess it wasn't only those ones up here. Yeah, that's well used. Oh, so there's the regulators we saw, the transistors, and those come up to this board here, which is a power supply. A bit of a switch mode power supply of a transformer there. I don't know where the power input connector went. I suppose it's on this, is it? Oh, it was on the back part. Okay. So that means the power comes in through this, and there must come out these, a couple of these quite thick wires here into that. And there's these brown and black wires which go up to there. Yeah, that's the main power for all the boards. Looks like there's a bus track along there. That must be the audio stuff. I wonder if that will come out. It might have wanted to come out, I don't know. Let's just take a look. And it comes out. Some kind of op-amp, Japan Radio Corporation, or whatever company. So that's a video output as well. There's shielded wire there from the BNC connector, but then there's no shielded wires coming off this board, so it just changes to whatever, a non-shielded wire. So that's for their own special microphone, or their JVC branded one, and then another microphone external type can plug onto there. Don't know if it will have phantom power, possibly not, since there's no switch for that. I guess they put shielded wire on that because it goes down by the microphone input signal, so you probably don't want interference from the video signal onto the audio input. Okay, so that's the little power supply board in the bottom there, with a weird looking 4-pin thing, which looks like a looks like a Hall effect sensor, but it must be some kind of transistor thing. And then some other IC there, 9-volt adjust pot, interesting colored diodes there, probably Zeners. Okay, that's pretty good. Let's have a look inside this remote adapter thing, camera adapter. It's got all the shaped stuff. Yeah, that's a JVC special, having that type of connector for S-Video. Not easy to find connectors for that. What is in here? Probably not much. Oh, there's a bit. No, the screws are not retained on this side, so maybe you're not supposed to take this side off. Also quite tight, maybe they haven't been undone before. Oh, the whole thing comes out if you try and do that. Yeah, why not? I could take this plate off. It's got a floating connection there. These little washer things. Are they retained? Looks like it. Yeah, that's the other side of the connector. So this thing can all come out as one piece. That's quite neat. Oh, except that. Oh, that's the battery connector. And unplug it. Some other flexes. Fly, whatever. So that there, VTR connector's got a flex coming off of it, which is this one here. And that's just a board to board. Look at that chip there. It's got like heatsink type things on the ends there. Goes the whole way across. It's like what's in the Viewfinder. Yeah. HA11423. There's HA11247. Don't know what that does. GL Genlock. Okay, so this will do the sync organization, locking the camera's sync to an external video signal, and that's VP. I'm not sure what that is. It has got RGB adjustments. I guess it's some sort of output amplifier. Yes, and there's a fuse and various things to connect it all together. So there's that arrangement for all these switches. There's the Genlock configuration stuff, setting the phase, and some audio and selection of stuff. Is that low, high, or both for the VTR trigger perhaps? And I don't know what RM is, maybe that's, oh, it's that I guess, RM, remote VTR on there, and 443, so that must mean for outputting on that connector, presumably. Ah, look, you can tell, you can use this div switch here to choose what comes out, perhaps. YC RGB auto or component. So it's set to auto. So I don't know how that automatically decides. Maybe there's a pin on this that chooses what you're getting. So those look like video output amplifiers. BGR. A video switch. Maybe that does some of the decision making when you're deciding for what output you want to use. So it's got a sync separator, amplifier, an error amp. We've got the service manual here. Let's take a look through it. Well, they give you some interesting information here. Safety check after servicing. I thought it was interesting that they want you to do a dielectric strength test as well as an insulation resistance test. It's good that they tell you about this stuff. And leakage current, earth continuity, grounding, and then they give you the specifications. Standard insulation resistance test at 500 volts, and you're looking for greater than 10 megohm or greater than 1 megohm depending on the region. And then additionally a dielectric strength test at 1 to 3 kV for 1 minute. I thought this was more of a type test than a routine test that you'd do, but I guess as things age and moisture gets into bits of the circuit, you'd want to make sure that it's still got good insulation, especially inside dodgy transformers. So there are instructions on how to use it, all the bits and pieces, what all the controls do. There's the microphone that you can get that plugs into that little round multi-pin connector. Battery. Other types of adapters, so there's a built-on AC adapter you can get. Or there's this, which I thought I had one of these, but it's actually something else. And I think we should take it apart anyway. If I can find it, wherever it went. So I'm pretty sure this thing, it looks like this. Remember what that looks like and we'll switch over. So I've got this thing, which looks the same on the, like the same battery mount as on the camera. But on the front it's a camera connector, it's not the 12 volt connector that I was expecting. And the cord it came with plugs into there, but the other end doesn't fit any of the cameras that I've got, so it's a bit bizarre. So presumably the correct cable would have the VTR connector on the other end, so you can power it and then get the sync in and out. And also audio and a trigger. The other thing that's quite bizarre about this is it says AC input 120 volts 60 hertz, and there you actually look on the back and it says AC input 220 to 40 50 hertz. So anyone's guess. We should open this. Let's see what its deal is. It must have a switch mode in it. It's pretty light. So I'm guessing it's a universal AC input. They just didn't say that. They just put different things in different places. Anyway, service manual. They give you the pinout for the 12 volts. That's good. How to hook up the stuff. Oh, there's different is that sub-carrier frequencies for the S-video output. Oh yeah, so they've got one with a 14 pin to 26 pin. Oh, you can get the 10 pin version, which is what you'd need for that power supply I've got. Indicators, the menu. Joining it up to a special effects generator, syncing multiple cameras together, setting it up. Specifications, 1/2 inch CCD, dimensions there. So this is interesting because it shows it with a VTR that would use that weird handle with that hinged thing. So there it is, joining onto a BR-S410 recorder. More instructions. Recording procedure. Indication and character display. The different things it can show on the screen. The shoulder pad. Okay. Installing that. Circuit description. Here we go. The color separation prism employs an RGB separation system and has the same structure as the prism in a 3-tube camera. However, the spectral characteristics of the CCD are such that it has high sensitivity for long wavelengths, red, and the system is different from that used in 3-tube camera. What? In front of the prism, a filter for cutting infrared rays is provided to correct the excessive sensitivity in the infrared range. So that was that bluish thing that has a bit of mildew or whatever growing on it at the front there. So it tells you about CCDs. CCDs used are manufactured by NEC and have size of 1/2 inch and a pixel count of 688 by 485 for NTSC and 668 by 575 for PAL. They're designed for horizontal resolution of 500 lines on each channel. And then there's some NEC chips Use an interline transfer system and exposure speed shutter can be selected. If a malfunction occurs in any of the CCDs, replacement of the defective CCD is impossible without the correct alignment. This makes it necessary to replace the whole assembly, incorporating 3 CCDs. CCDs themselves have a semi-permanent service life, so care should be taken not to damage them electrically when the camera is being repaired. In addition, the camera is designed so that the degree of discrepancy in registration at both the telephoto and wide-angle lens of the zoom is expected to be within 1 TV line. Okay, it's in a sealed case in the central section of the camera. The block constrains the Prism CCD IS board image sensor circuit, SA sample and hold, DR board, which is the drive pulse generation circuit, and DR2 CCD sampling bias circuit. These components are installed in a shielded case to prevent them from radiating pulse waveforms which would interfere with other circuits. Very interesting. The circuit used is common for RGB, and the CCDs are mounted on the PCB using connectors, as we saw. The CCDs output video signals via buffers, emitter followers, and their waveforms are shown in the figure below. Preset field through noise pixel reset timing. So that's per pixel you get this business going on. So we could get into a lot of complicated stuff about how the CCDs work. The encoder. The KY-15 encoder is provided with the output systems shown in the diagram below so that the camera can be connected to various VCRs. There is a 0.3 microsecond level and timing difference between the SVHS recorder and the M2 recorder, so the signal is output after being switched. For the same reason, the 2 types of color signals are output, i.e. component and SC modulated color signals. Ordinary composite video signals are also output. This is the only output system provided with a circuit that cuts the camera signal when the JVC recorder is in the playback mode. So the video output shows the playback signal, I guess. Everything else just continues to show the camera output signal. So here it is, coming in from the RGB. Sync is added to the Y. Okay, so that transforms the RGB into the component signal. Sync is added in to that component, the Y, which is the black and white video, which then that can create the Y output. A composite is then can be created by taking the Y and combining it with the color difference signals, and then the chroma output for the S video is output similarly, and then the 2 component signals which are directly out of here through buffers. CPU, so there's a digital to analog converter and then a sample and hold, and then that's how it does its adjustments by producing analog levels which are then going to the various circuits for adjusting gains and other things. And then there's also some analog to digital converters, so there's some readings from various parts. Character generator IC7, and then there's P10 PIO, so that's all the digital inputs and outputs. The auto white balance works. Diagram of the automatic control, so that's the CPU, analog to digital converters for these, error detectors for auto white balance, the digital to analog converter for controlling iris gains, and the gains, voltage controlled amplifiers, how to replace the fuse, taking all the bits apart. And what you need to do the servicing, you get an expansion board so that you can have the cards outside the unit while it's powered up, joined up through this expansion or extender board. This setup for calibrating the test pattern with lit with halogen lights, and then there's a power supply adjustment, encoder adjustments using a vector scope. Very good. And continuing adjustments, packaging, All the bits and pieces. Exploded view. Wow. A lot of stuff going on there. We've got parts lists. Then we've got charts and diagrams, and they give you some information about the components. Surface mount components. Chip parts. Surface mount. Different diodes. And so now we've got the schematics and board layouts. And you can see that board for the CCD that we were looking at before, where we were tracing that tracks from the transistor. So here's the schematic of it. So there's that buffer on the output. So that's the image sensor, and 3 times. So that's the board where the 3 sensor data come into this, but I think that's a different version. Maybe. No, it's just up that way. There you go. Some things will be different between PAL and NTSC. Oh, they don't tell you what's going on inside these, they just give you a symbol for it. So the other signal going into there was the clock. DR1 board, PR1 board, PR2 board, CC1 board. Is that the one where the image sensor data comes in? That was PP board, CPU board, character generator IC7. So that's what that that wider than normal chip is. It's the character generator. IC9 is the auto setup memory. That's that. The DAC sample and hold thing there, maybe? IC4. Oh, there's that thing. A module. Okay. Oh, that's that little audio board we looked at. The op amp, JRC. And that's the power supply. Oh, so that's the backplane MT. This thing here. And so that doesn't show the PP board that I can see. Oh, it's up there. PP board. Okay. So now we're in the back. The VTR adapter thing. Yeah, so here we go. So this is the back part, the thing that we just took apart. The camera adapter. And it's got a description there. So it's got switching and buffering, which will be on that VP board, this one. And then it's got the other board, GL board. Actually, let me give you that small view of that GL board. Genlock, this one. It's got a transformer looking thing on it. So that takes the sync input and does stuff to it. Phase comparator. So it locks the camera head to an external sync signal. I just want to know what that HA chip is. Let's have a look at schematics. How to take it apart. Exploded view. All the bits and pieces. GL board. That chip is a phase locked loop. There it is. So that's what's going on inside it by the look of it. There's a Zener inside it. Nah, that's a different chip. That's not the one, that's D. So that's that chip there. There's the phase lock loop. That's what's going on the other boards. That's the overall. So they keep it a secret what this chip with the little heatsinky end things are. This is there. Scan's not high enough resolution. So it's a subcarrier phase comparator by the look of it. A noise protection external horizontal generator and the horizontal phase comparator, internal horizontal generator. Okay, so we'll use one or the other. If it doesn't have an external sync in, then we'll use its internal one. This is sync separator, which is CBM1, which is this thing up here. It's made of two circuit boards glued together. So it's a subcarrier phase comparator. Internal subcarrier. I don't know how much of that will end up in a video. It's just a look at the various bits and pieces. And my only medium understanding what's going on with a lot of it. Okay, so that's the service manual. Oh, so what we wanted to do was see what was that little board, this little thing. I'm not sure if that was shown in there. Is this fallen over again? I really want a block diagram again of the camera. There. Is that it? I think so, the VHS1. Yeah, so it is an official thing. Does it tell you what that is? Is that this here? I think so. Look, it shows the wires being tacked on to various places. I think we've found it. So it's got 18 volts, switch 1 in, VH in, switch 2 in, ground, and VH out. Okay. And there's a chip of 4053 with only one pin connected. Yeah, it is a 4053. Ah, no, hang on. That's what's in the 4053. That's just the unused inputs grounded, linked out, and the power supply. Okay, that's weird. So it's got a transistor, a diode package, a transistor, capacitor for bypassing the power supply, 2 resistors, and that's it. There's 2 switching inputs, which both go to the control of this thing, which looks like an analog switch, which can go between VH normal in and just some bias thing, VH out. So what chooses the switching? S1, S2, in. Oh, in from another board, isn't it? And what is VH? Vertical height, maybe? Strange. Some kind of modification they've done for something. Vertical height, presumably. Does that mean you can set it to underscan it or make it widescreen? Can't do text searches on this file because it's just pictures. Otherwise we'd be able to search and see if that's mentioned anywhere. It's got a trim pot on it, so I wonder if it shows up on these somewhere. Alright, that's enough of that. Okay, I'm gonna put this thing back together somehow. Okay, that goes that way. Yeah, good lock-in for the JIS screws. It's when a good screwdriver fits the screw properly. JIS screws lock in really good, as long as you got the right screwdrivers. You can tell it's JIS because they got a little tiny dot, small dot there beside the cross. That's how you know it's JIS. Though they don't all have the dot. Yeah, so it's actually a 1, even though it's such a tiny little screw. Yeah, so with JIS screwdrivers, the screwdriver looks too big for the screws normally, but the points on the screwdrivers are quite sharp. So the tips of them do go into the smaller screws and fit really well. You determine what size you need just by putting them on and seeing if there's any play side to side. So this number 1 looks like it should be able to fit these, but it's too small for them and it doesn't fit tight. So you get the number 2 and it fits perfectly, really tight in there, so much that you can hold up the screwdriver by holding onto the screw almost. And some of them lock in amazingly well, so you can hold the screwdriver up by the screw. It means they haven't been munted yet. If someone else has undone the screws with the incorrect screwdriver or they've done a poor job of it, the screws will get damaged extremely easily, so you've got to be careful of that. As soon as it cams out once, then the screw is screwed, and it will be very difficult to get it in and out properly after that. I think that was it for that thing, wasn't it? It was pretty simple. If it's a Japanese appliance or equipment, then it's pretty much guaranteed to have JIS screws. Now, a lot of them will be these Sims type where there's washers on them as well, split washers and also flats, and they work really well. They're torqued up appropriately. A bit of stretch occurs when it's done up to the correct torque, and then that's holding very tightly, and when you come back 20 years later and try to undo it, you'll hear a loud snap when it lets go. You might be able to get that. You hear that click noise that it made? A quite sharp click sound of it breaking free. Yeah, depending on what it's screwed into, that can be really loud, which is quite satisfying. Okay, last thing. Let's look inside this power supply thing. Okay, we're going to take apart the power supply. Perhaps try not to mix the screws up, otherwise it's going to be harder to put back this camera. Put the camera back together if I decide to do that. I'm not sure yet, might just get chucked in a box and put aside for a while for a rainy day. Although it is a rainy day right now. Probably have to take this handle off the top. Wow, so there's just one block of stuff and that's it? Wow, look at that thing. It's just a sealed up aluminum thing. Let's undo it. I'm going to take this apart and see what's inside this. It's not very often you get the power supply with the cameras. All that good stuff and all the special cables are normally being thrown away for you, and you just get the camera by itself, that's it. Which is really sad, because a lot of those cables with special connectors on them are hard to find, and if you can find them, they're expensive. So we can bring it out. And so it's not a connector at that end, or that end, so it's have to sit here. It's like the top just comes off. There's 4 screws on little outrigger post things. You get a good crack when it breaks free. Whoa, look at that. Switch mode power supply. Wow, look at that connector on the input. Okay, let's take a look at this. So we've got some kind of control IC, presumably. Optocouplers. Is that an LM393 comparator, maybe? Where's the input and output? Okay, so the AC input, fuse, RFI, capacitors and common mode chokes, Y caps there to ground, possibly some kind of inrush limiting maybe. What's that, 8.2 ohm resistor, 3 watts. Diode rectifier, diode bridge rectifier, input caps, Will this have an auto switching thing? Could do it to take the board out to determine that. It might be that. The technique to allow it to run on a universal input, where for the 110 volt setting you join the center point between series capacitors to neutral, and then with the rectifier and the caps acts as a voltage doubler, and then for the 230 volts you leave that center point disconnected, so it's just a full wave rectifier. So in both cases you get around 320 volts across the two caps, and there are little chippies. Maybe that thing for doing that switching automatically, which is what you'd see on a device that doesn't have a user accessible voltage selector switch. And then the other approach is you just make your switch mode wide enough range that it can just switches. It doesn't matter what the input voltage is, or you put an active PFC booster on the input, so it will just boost up whatever the input is to the higher voltage, to 320 or whatever you need. So there's screws coming up from the bottom, but there seems to be something else holding this in. There's no more screws accessible from the outside. I wonder if it's just the paste. Probably is the paste. Yeah, there you go. Paste. So that will be the input switching transistor, and that's probably a rectifier for the output. Probably. Yeah, and that's an output choke. Smoothing. Wow, that's a weird... That rectifier is weird. Normally the plus and minus of the output on the outer legs and the DC is on the inner leg. But you can also see someone's desoldered a link there. So maybe it's not automatic and you have to configure it to 230 volts, and it looks like someone's done that by removing that link. Very interesting. So it's not an automatic switching, which is weird that both labels are printed. I'm sure I ran this on 110 volts, but I can't remember. I don't think I ever actually used it because the cable it came with didn't suit the camera. I'm sure I plugged it in and the lights came on. Yeah, so anyway, there's a control chip there, PWM controller, which will be switching the base of that transistor there. There's a base driving transistor, and that comes off one of the pins of the chip. And you've got an auxiliary winding there, which will be providing power to this primary side. And then that 1K resistor there will be the bleed off the DC into that circuit, I think, to get it to start up before the first switching pulses, when that will start generating the voltage. I think that's what's going on there. It's regulated with a Zener by the look of it. Zener regulated power supply with that pass transistor, and then that goes on through that diode, so it can't backfeed into there. Is this common with that rectifier there, capacitor? So that's the power supply of the controller chip. And there's two optocouplers, both run the same way, so they're both for controlling it, that can't give feedback. Is that true? That's got AK on both sides, so that's weird. Maybe that's some other kind of thing. Maybe we should look that one up. And then there's a comparator, and what sort of voltage reference it's got. Then adjustment. Don't know if we use a TL431. Yeah, we'll get thermal paste all over my fingers, that's good. Yes, that is an inrush limiting and also current limiting resistor, because it's in series with the incoming supply with no way of bypassing it. Now it must be a forward converter then, with that's the extra inductor on the output. So it's like kind of like a buck converter after the converter. That's what's going on there with the way that diode is configured. And there's a 0.1 ohm resistor in series with the output, and it's in series with the ground side, and then there's a track coming off there, so it's possible to sense the current. There must be an overcurrent detection type thing, probably with this comparator chip, so it must be able to shut off if you exceed the current, or dial back, which maybe is why there are two optocouplers. They also conformal coded that isolation boundary there all the way up to there to increase the creepage. Oh, yeah, that would be mandatory because you see they've had to run, to keep the board single-sided, they've had to run tracks around the inside of the isolation gap. That is very frowned upon, to run the track on the inside there, because you're decreasing the creepage across the board surface between the AC main side and the grounded side, which the user can touch. Yeah, I would not accept that sort of thing where I come from. And that also looks a bit close there. Yeah, they probably ran out of space because you need functional creepages across here for the AC, and then you need the reinforced isolation creepages across here for the safety. So it probably made it too difficult to move that stuff over and keep that gap bigger, and that area is already full. So their solution was to paint some resin type stuff over that part of the board to ensure it stays clean and seals those parts in, so it's more like a solid insulation rather than a surface. It's like creepage across a surface can be compromised when you get dust settling on it and a humid environment, and then you can get tracking. And the same thing's happened over here. There's a blob of that same resin stuff there where those tracks get a bit close. That looks like a filter clamp type thing to stop the transistor from being over voltage when it turns off. Resistor, capacitor, RC filter thing, and a diode, and that comes a bit close. Wonder if that was like an afterthought, or it was different originally, and then they had to put it in to stop blowing up the transistor or meeting some EMI requirements. So then it had to get closer, and then that had to get put in to meet the standards. Interesting. Let's look up some chips. Okay, I've looked up data sheets of some of the parts on this power supply. First one we'll take a look at is this, the UPC or MUPC 494C. It's an NEC switching regulator control circuit, and they've got, so it's similar to things like the UC384X series, pretty common for generic switch mode converters used all over the place. You can see the layout of the chip there, error amplifiers, reference oscillator, and then there's two output transistors which have uncommitted collectors and emitters, which is quite interesting. So you can configure it for high or low side however you need to drive there. Regulator, and you get to access both sides of two comparators there. There are some example circuits which are interesting. That shows how to hook up everything. Put a current sensor on there, and then your voltage feedback on that amplifier. So what they've done here, this example, they show how to drive the switching transistor through a transformer, so it's isolated. On the output there, so that's a Ford converter, and you can see that output configuration is the same as what we saw here with the output inductor and then the dual diodes there configured. Exactly what they've shown there. So this is a pretty standard Ford converter. So if we look at the layout of the chip here and then reference that onto what's happening here, we can see that the comparator there, which is what they show as error amp 2, is not connected up. They've grounded the negative input and the positive input is going up to there. I think it's the other way around. That's ground there, pin 7, and that goes down there to the non-inverting input and the inverting input. I think that's the reference output. I think there, pins 13, 14. Whereas the other error amplifier, error amp 1, this one here, they have joined the non-inverting input to the collector of the transistor in the optocoupler, the feedback optocoupler, and then the collector of that goes to the anode of this interesting device, which we'll have a look at shortly. So when the voltage hits the threshold set by the circuit here, the output voltage, this will turn on the LED in the optocoupler, and then you'll get a feedback signal there for this to stop switching on the primary. That's how the control works, and then as the voltage falls off on the output, eventually it will turn off the optocoupler, and this will start switching on the primary again to bring the voltage up. Now, so that's that optocoupler, just a generic photo transistor, that thing there, PC817. So that controls the voltage regulation. And then we got this UPC393, so that's that thing there, a dual comparator, which is probably being used for monitoring the current across this 0.1 ohm resistor and the output voltage off of something. I haven't looked up exactly what that is, but it doesn't really matter. Probably to do with this. That will be the voltage set variable resistor, so wherever that joins itself up. And finally we've got this interesting thing, which looks like it's a diode on both sides. You can see it's got a gate there, a G. So this is a photothyristor coupler. So on the secondary side of the circuit, the low voltage side, we've got the anode and cathode of an LED. And then on the primary side of the circuit, the mains side where the control IC is, we've got a thyristor. I reckon, not sure why the gate comes out of that, because surely the gate's controlled by the LED on the input side. So what I reckon is happening with this is it's an overcurrent protection using this 0.1 ohm resistor. So if you exceed the output current rating of the power supply, the output of this comparator, one of them will change state, which will switch on this thyristor and latch it on, and that will prevent this from switching, so it will lock the power supply out until you've turned it off, like disconnected the AC input, and let this part of the circuit discharge enough for the thyristor to unlatch. Because as we could see, the collector there goes to the anode there, and then the cathode goes to whatever that is, a reference voltage or ground or something. It'll go to a reference voltage, or a reference voltage across there. Yeah, so reference voltage through the thyristor, through the opto transistor, and then the emitter of that goes into that comparator. So if you trigger the thyristor, it will lock the circuit out because it will keep this path conducting. Does that even make sense? You'd think for that to happen, you'd have to have these two things in parallel. There's another track there that I hadn't seen before. So the reference is going to both the anode there, the collector there. So this cathode, where does that go to? It goes to that. I'll have to work out what pin that is. That's pin 4, which looks like pin 4. What does that do? Something to do with the oscillator, isn't it? Dead time control. Yeah, maybe it just yoinks it into a state where it won't run anymore. That's what I expect will be happening. If you exceed the current rating, thyristor turns on and it blocks this from operating until you've powered everything off, let it discharge so the thyristor unlatches. So there you go, that's a switch mode power supply from back in the day. I don't know if there's a date code on any of this stuff that we can look up. I think because they're Japanese components, they don't use the Western style date codes, so I'm not sure what we can use there to find a date. Could be 1986 maybe, I'm not sure. I think that would be similar to what we saw on these chips over here on the inside the camera. They were 85, 88. Yeah, similar sort of deal. Anyway, I think that's the JVC KY, whatever its number was, 15. Yeah, KY-15. It's not the full thing yet. Let's have a look at one more part. The viewfinder. So we took a little bit of a gander in this earlier, and we even powered it up. It's probably still got voltage on the tube. Very dirty and corroded viewfinder. There's a service manual for the viewfinder, so we should take a look at that. There we go. September 1987. So it was a separate service manual and I had to buy it. So the input is a composite video signal. So it's just a standard little video monitor, no other special features. It's an adjustment procedure. Brightness, contrast, focus, height and linearity, vertical hold, horizontal hold and size. And how to disassemble it, how to remove the flex PCB, which is there. Packaging, look at that complicated packing that it has. How to understand the part numbers of the screws. Wow, that's quite interesting, isn't it? And there's the exploded view. Wow, look at all that stuff that it takes just to have a viewfinder. All those things in the optical path. All the rings and plates. There's a little tube and the housing for it, and rings and the deflection. The plug on the end. And here's a schematic PCB layout. Parts list for the PCB. The schematic, that's what we came here to see, wasn't it? So the input connector to the viewfinder, it's got the tally light, it can be turned on and off, and there's also a tally light inside there, so the camera operator can see it, but externally it can be switched on and off with the switch. Ground, the video signal, ground. Interesting that ground there goes for a 0 ohm resistor, there's that one solid. Video signal, 12 volts in, and the battery alarm, which will be another one that just goes to an LED and nothing else. So pretty much all you have to do is join 12 volts ground and a video signal, and you got a mini TV thing running, which is quite neat. And it's a standard 1 volt composite video signal. So let's follow that. The video signal comes in, it's decoupled with a capacitor, 33 mic 10 volt. Then there's a buffer, that will be some power supply. That's a 9 volt regulator there, linear regulator. So that's 9 volt bias on that transistor there. So then the video signal splits to two places over here. To another, it gets decoupled from that network. And then down here, decoupled again from that network to this one. And then this is the Hitachi chip, which does the sync separation. That's all power supply. It's got some kind of thing on there from the sync signal. Switched. Okay, so when a video signal is coming in and the sync gets separated out of it, so that's a power supply rail, 9 volts. Video signal through the buffers, through there, into a sync separator, V sync, V drive, horizontal pre-drive. So the vertical sync comes out here, vertical drive, vertical sync comes out, and so that's the sync pulse will be causing this to switch on and off, and then that will be letting this, when that's turning on, it will be discharging this capacitor which is being charged from this 100k, so that will overdrive it and allow this voltage to reduce enough to turn this PNP on, which will turn that PNP on, so that will allow current to flow 3.9k down to this, which is switched to 9 volts. So when that has voltage on it, it must turn on other parts of the circuit. So that goes up to here, and here the sync signal goes through the stuff. Lost track of what's going on. Okay, so the flyback transformer's there. It's connected to 9 volts through, I think, the X-ray protection circuit. Yeah, that business there. Okay, so it connects to 12 volts through that, which I think is the X-ray protection, the blanking, and then the bottom side of the primary of the flyback goes to this, which looks like a FET, and then that goes from the horizontal drive. So when the horizontal drive signal is running, that switch 9 volts also goes to there. So when the horizontal drive is running, it switches the flyback transformer at that rate, and that produces the high voltages and other voltages that the CRT needs to operate. And there's the heater, and then there's the main high voltage anode, and then there's the grid power supplies going to various places, coming from here where there's brightness and contrast. So the video signal, the brightness part of it, rather than the sync part of it, comes out here, has some things done to it, and then that goes there into grid 1 to drive it gates the electrons flying off of the heater to vary the intensity of the beam that strikes the phosphors on the screen. And so these waveforms show you what it looks like when color bars are applied. So you just get a pulse there, because that's coming off the sync. The deflection coils for the tube are driven off of the sinks that are separated out by this chip. Horizontal here, some drive transistors for it. Horizontal size adjustment. Vertical similarly come from this side, and then there are adjustments, vertical size, linearity, and some drive transistors there. And so it's got this push-pull type arrangement there off of that vertical drive onto there. Horizontal is that FET, and then some stuff on the other side. Is that a power supply? Yeah, 9 volts. So it's a FET driven through this transistor by the look of it. That one there. Oh yeah, that's the X-ray protection thing, which goes into that. Very good. Oh, that's what the waveforms, the deflection waveforms look like. Yeah, that one's just switching to ground. What will happen is when that switches on, the current will start building up in the coil. You can't see there because that's just showing basically that getting switched to ground, that's it. But the current flow will be building up in the coil and then switched off, and then there'll be a voltage peak before it gets turned on again. A mini black and white TV. Alright, I think that's sufficient exploration of this video camera and its power supply. Camera is being put back together. Got most of the bits in. Just pushed in this front part and then accidentally touched those again. Maybe we should have cleaned them out while we had it apart. Anyway. And putting in screws. Now this is the camera that the picture was black and white. I wonder if there's a way, maybe it's just the output encoder board we can change and that we sorted. Or was it set to the wrong setting? Did we check that? The board that's got that little rotary switch on it. Let's just rummage in this tray and find some more screws. That's from all the stuff that I've torn down for scrapping recently. Okay. Is that it? Yeah. Because I've also lost the screws for holding that on. Don't understand. Nothing fell on the ground that I'm aware of, and I don't see anything hiding off the edges over here. Got the stand, whatever that thing is, the handle, this base part, the back thing, which we put back together, this little bottom cover thing. So was it those screws there that held this back thing on? And at the top it's just a little locating post by the look of it. Oh, we lost the screws for that as well. That doesn't make sense. Where are the screws? I didn't put them out of the way. That is so weird. Did I build them into that power supply thing? Which I also put back together. I don't know. Don't understand. Anyway, we'll try and find something suitable in this collection. I'm gonna get the matching black coloured ones, but there isn't so many with the same head. It needs a really long screw. Okay. It seems to have threads on both parts of it. Don't understand anyway. Yeah, let's not worry about that for now. Just wanted to try it out now that we've put it all back together. See what it does, if anything. That thing there used to be up here. I don't know. What was holding that together before? Must be that. Gone crazy, I don't know what's going on anymore. Was that in there? Even if it was, how does it work? This looks more like a tripod mounting thing on the bottom, but no, I think it was like that. I still don't know how that holds it on though. Anyway, whatever. Let's crank the monitor up. Bizarre turn of events. I suppose I could look at the other camera since there's two of them. The handle on that one's completely different and it goes over that back part. Which suggests this one was never attached, it was just the this base thing that was pushing them together. Anyway, let's get a viewfinder onto it. The connector is in the viewfinder. Get the output connector. Get the power supply in there. Here the iris adjusting. There's the bars. There's the video. So it still works as well as it used to work. I suppose we should just leave this side open to see if we could have adjusted something to get that color back. If that PIX output thing was set wrong. I guess at least that will tell us if one of the channels is missing. Okay, let's adjust this and see what it does. Oh, fuzzy. What's that? That's position 2, blue. So that's red, green, blue, very noisy. 3 is supposed to be the color output, and then 4 to 9 is auxiliary. Don't know if there's anything else there that could affect the color. We put it on bars. That's good, isn't it? That's the red component, the green component, and the blue component of the bars. So all 3 channels are working, you just don't get a color signal out at the end. Which could be because there's VTR selection. No, I don't think so. Anyway, camera works as well as it did before we started, so we haven't made it worse. And when you push display select inside the viewfinder, or on the viewfinder, some stuff appears, various text thingies. Great, till next time.